morning. Good afternoon. Good evening. It's Monday again. Seems like no matter what we do, we can't avoid them. Good morning, Nils. Good morning, Christos.
Morning.
Hey, morning, everybody.
How are you? Did you have a good weekend?
It was stellar.
That's an open question for anybody to answer.
Yes. Tell us, friends, how was your weekend? Salty Sea Cow says, good morning. Good morning to you, Salty Sea Cow. That's a lovely handle. It was short. I know. It is short. The kids were saying, like, I hate Sundays because tomorrow is Monday. It is the general feeling.
Yeah, my
Are
daughter
your
didn't
kids
want
going
to go.
back to school?
Well, back in school as in they have to attend school online. Thank God.
Okay.
Although, in saying that, our district decided that it's safe enough now to open schools again. And we were raging because they said you can either stay online and do online tutoring or lessons, or you can follow the hybrid model. And like, no, we don't want the hybrid. In fact, 75% of our school said no hybrid. They want to do remote. But the problem is that they're going to change all the class and all the teachers now, because some of them will go back, some of them will stay online, and they're reshuffling all the teachers. So halfway through the school year, we're going to have a brand new teacher to work with. Awful.
Oh,
Awful.
that's pretty bad.
I know, man.
My kids' schools have never shut off. They've been in school
Yeah.
since the very beginning.
You mentioned that.
So they send out COVID stats, and they're like, oh, we've managed to avoid any sort of significant impact in the schools, so we're going to keep them open. Problem is, it's pretty easy to say you've had no cases when you when you don't test anybody. So
No tests, no cases. I mean, it's simple, right?
yeah,
Not to worry about that. The logic is infallible.
Yeah. So so that's kind of the way they are. I mean, right now we've got a 22% positive rate in our county, and yet they're still like, oh, there's only been one case at the schools, so I guess we're okay, right? And so my kids still go to school. I mean, at this point, we've all probably had COVID in our house 4 times because the kids keep on bringing it home. But, such is life.
Such is life. Robert Table says they got a little bit of snow, and he got the kids to actually shovel the driveway. Well done, man. Living the dream, that's for sure. I hope they didn't charge you for their work. And we have Code with Sean here, who was with us on Friday. I don't think he can get enough of us. Thanks for coming back, Sean. Hope you had a nice weekend.
Yeah. So
Yeah.
right now, my kid's school has 5 active cases, and yet he's still at school.
Oh, God.
My daughter didn't want to go to school today. She's like, I don't want to go. We said, well, you kind of need to go. And she's like, no, I don't want to. So she's upstairs.
Who can blame her?
Well, so Saturday I went to go see my P's. We hung out for a little bit, whatever. And I got home and I was just standing around and I tripped on a rug.
Oh, no.
Like, on the floor or whatever.
Uh-huh.
And I fell backward and like my knee went too far or whatever.
Oh,
He did,
God.
Like knees are only supposed to go back so far, right?
Uh-huh. Uh-huh.
And so mine went too far. And when I was a teenager, I played basketball. I know that sounds completely ridiculous to anybody who has met me in person, but when I was a kid, I played basketball and I twisted my knees pretty badly. So they've always been kind of
Wobbly.
a little
Sensitive.
unstable. So anyway, so that meant that Friday or Saturday night and all day yesterday, I laid on the couch with ice on my knee and a compression sleeve.
Ow.
So
But
yesterday,
are you feeling okay now?
No,
Oh, God.
I'm still quite slow, and it took me 20 minutes to hobble down the steps to get to the basement, but that's okay. But yeah, I wish I could have dunked on LeBron. LeBron and our birthdays are like a week apart. Same year.
Same year?
Yeah. So let's see, when was LeBron's birthday? Anyway, so I'm pretty sure that yesterday I fulfilled my. Oh no, wait, he's 2 months older than me.
That explains it. He's got all the
But,
pictures because he's older.
But yeah, that's the difference. I'm just 3 months behind.
You're still catching up, man. You can get it. Don't worry.
So yesterday I fulfilled. I'm pretty sure I fell squarely into old bastard territory yesterday because I laid on the couch with a sleeve on my knee, with a cane to hobble around the house with, I watched golf, and I took my blood,
What happened to you? I only left you for 2 days, man. You were fine on Friday.
and I took my blood pressure like 4 times. So I'm kind of done. I don't know what's happened to me. This is such a swift fall from grace. So yeah, I don't know. And even today, look at this. I've got a shirt with a collar on it. Like, what year is it? I just feel very old today.
Time to hang up the gloves, my friends. Hit retirement. You're done.
I was all ready to go to the gym this morning, and then because I found a gym down the road from us. It's called The Office. Okay, now there are other.
Are you sure
there
it's
are other,
a gym?
It is a gym. There are a few other gyms nearby, but and they're typical, like Planet Fitness style places. Mm-hmm. But this place is local because they support a local place because they need all the business they can get right now. And I'll check my lawn, Robertables, by the way. Make sure you're not out there. It's kind of icy and gross here, so. But anyway, this place called The Office, it's actually like a gym for bodybuilders. Like, everybody
Hardcore
there,
stuff.
like, they all wear tank tops that are super low, And, no, it gets worse. On it says, like the word shenanigans, right? Like shenanigans. Well, theirs says shenanigans.
Smart.
So I went to talk to the guy, and I was like, hey man, like, obviously I'm not trying to be like
Jack out. Yep.
but he was like, oh, you totally should. You got the frame for it. I'm like, I don't know what that means.
Here, start with these performance enhancement drugs that will get you there, and then you can join the gym.
So I don't know. So maybe I don't know. Maybe we'll see what the next 6 months brings. Maybe by then I'll be I'll just
competing.
We'll see if my neck gets any wider. If it turns into the same width as my head, then you'll know what happened. But I'm actually kind of excited about it because it's a local place. And the thing is, everybody there is like, you talk to them and they're just super nice. So, it's not like it honestly doesn't feel like a typical gym. Like I went to the YMCA and it was packed and everybody was just kind of a clown.
No.
And people were just kind of like, pushing you out of the way and stuff, which was annoying. And this place, I don't know, like they're all so into themselves. It's like, that's perfect. Nobody will even know I'm there. So
I can't go to a public gym. The last time I went, they kicked me out because I dropped the weights. I was power cleaning,
you're that
right?
guy.
So, yeah, I cleaned, and they had rubber mats and they had rubber plates. And what makes more sense than drop the I can't remember, 180 pounds. So I dropped it, and then the guy that was responsible on the floor just ran out of the office, came to me. It's like, dude, you can't do that. I'm like, why not? It's like, rubber mats, rubber plates. I don't see the harm. Like, no, we don't slam the weights here. I was like, okay, so if halfway through my clean I fail, do I break my neck to save the weights? It's like, yeah, we don't encourage people to do this. Like, okay, maybe I should go back to treadmill then. And I left. That was the one and only time I used my gym allowance from work, and never again. I can't go to public gyms anymore. Although I think CrossFit, yeah.
This feels like the I lift things up and put them down guy. Have you ever seen that ad? It was a Planet Fitness ad. And the guy's walking around with what I'm fairly certain is a jug full of egg yolks, like a full gallon jug of them.
Okay.
And he says, and the guy's walking him through. He's like, "So what do you, what are your goals?" He's like, "I lift things up and put them down." That's all he says the whole commercial. It was pretty funny. So anyway,
Roberta Bowles says, if JP complains about any Azure stuff today, it's old man yells at cloud.
Is it only?
Maybe you should change your title to that.
So only Azure stuff. If I complain about other stuff, is that?
You can complain about other clouds, I guess.
Well, I don't want to do that because that looks bad. But
fair enough.
I don't know. Anyway,
okay.
I'll try not to complain too much. Anyway, sorry, Nills. Sorry you had to bear with us through all that. So Nills is back. Nills came to see us a few months ago to talk about AKS, and he's back.
And he missed the opportunity.
Yeah, he
with
liked
more
it so much he came
AKS.
back. So
you missed the opportunity to say, "I'll be back." You should have said that on the way out because.
Maybe I'll say that after this show.
So yeah. So anyway, good to have you back.
He was the
Nils.
best. He was the best. Arnold. Yeah. Welcome.
Thanks for having me.
I am a fan of the Governator, but so what you
It's a
got
busy-
for us today? You
It's
want
a busy time in your life, right, Nils? What are you doing these days, man?
It is a busy time, but as I told you before we started streaming, luck has it that I spent my weekends preparing for the show, writing chapters for a book I'm writing. So good, it all came perfect timing.
What's the book? Can you say?
Hands-on. Yeah, I can say it's a new edition of the hands-on AKS book, and I'll share the link on our chat here. There's a session available for free now, but as things in Kubernetes land evolve fairly quickly, we're now working on a third edition that should be out in about month and a half, 2 months.
Nice.
You know what they say about deadlines, right? Don't commit.
You know, I'd like to see people
Well-
start writing technical books in the style of like fantasy novels, like Harry Potter and the the non-linted YAML, or like the
I'll
Lord
do a
of
spell to Kubernetes app. How about
the
that?
Lord of the Bings. Like, I don't know, something that you could read or that your non-technical friend could read, and you'd both be thoroughly entertained.
I don't think you can entertain the two different audiences with a technical book like that. Although I could be wrong.
We could
Maybe
try.
I wonder if the Phoenix Project is one of those books, because that's a sort of fictional novel about DevOps. I've never read it. It's on my to-read list, but I wonder if that's like one of the technical books that my wife would read.
It's a great book, and it has wider appeal, but it's not particularly technical, right?
Okay.
Well, I've seen recently too, the other big popular book type seems to be people who, like, basically it's like notes from the field. It's like a field notebook, and it's all the people who are out in the world doing cloud stuff with their customers, or software places or whatever. And I think and they're just, it's almost like a book of essays. It's a book of short essays by lots of different people who are all out, who are practitioners, who are all out in the field doing stuff with customers. I actually think it's kind of a neat book because it teaches you everything in between. And I found one, it was a while back, and I just saw another one today. Somebody published on or posted on Twitter that they were doing it. Uh-oh, we lost Nils. We've annoyed him already, and he left.
I was like, screw you guys.
Yeah, so we were, at one point, we were going to do, at one point the name of this show was going to be JRR Token.
Yes. So
but
close.
It didn't really make sense as the name of this, as the name of the stream, right? So we thought, oh, that'd be a good episode to do. I'll get like my Gandalf hat or something, but I don't know. Like, I think I kind of wonder, like, long term, how to, like, you've got to update your book right now, right, Nils? And like,
Yep.
but I almost feel like the books, they fill that niche of between, well, these are pure docs and these are blog posts. They fill that middle area between real world, practitioner type experience versus what the original creators intended for it to do. And it's like how to be successful rather than just this is what it does, you make up the rest, right?
Yeah.
Yes, exactly.
So,
And I think that's the difficult piece is with books you also write for, I would say, at least with this book, I'm aiming at an audience that's newer to the technology, where a lot of the docs assume you've got two level of docs. I feel you've got like the level 100 introduction, and then you've got like the
400.
level 300.
Yeah.
Yes, level 3 400. This is how you do it, but the why is often forgotten. And I think
Yeah.
that's what I'm at least trying to include in the book as well. It's a very hands-on book with lots of examples, but I still want the why to be explained as well. Like what we're doing
Yeah.
today. I can show you just the how, but I think the why is even more important.
Yeah.
yeah, I mean, I think, especially when you look at like programming books and whatever, I think a lot of them seem to be like anybody can learn syntax, right? Like learning the actual proper syntax to make a program compile is one problem, but I'd argue it's probably one of the easier problems. Although I did do some Haskell once, and I was very much in the I have no idea how to make this compile camp. But I think generally speaking, especially big programming languages that everybody's using, C#, JavaScript, Java, that sort of thing. Like you can make a program and compile. It's really about why do you do things the way that you do? It's like why are you the way that you are? Like C# and injection, dependency injection, and why should we do this? And it's just the design of everything, right? That's more why would I do this rather than how. Like, okay, cool. Do I know that I need dependency injection? Like, why do I need this? Like, that's the question that people need to answer, and I think technical docs struggle to answer that question because they're written for anybody to come, well, you're going to use this tool, so here's how the tool works. I just saw Thindel's note. If Haskell doesn't compile, just add more parentheses. But
exactly.
But I think it's like, and blog posts sometimes give you all the why and none of the how. And so there's this really neat middle part of evergreen type stuff, right? That is, why do you do things the way that you do? And so it's cool. I'm interested to see. I'm interested to see your book. If you got a link to it, send us a link to the existing version. And
didn't I do so already?
Or maybe you did. Maybe I'm just not looking.
I did so already.
Oh, he did it on the OBS Ninja.
Okay, I have 98,000 different ways to be contacted. So
okay. Should I send you a pigeon?
No, I've got it now. Well, I live in South Carolina. A pigeon, somebody would probably shoot it, thinking it was a drone that's going to give them the COVID vaccine.
Target practice.
So cool. All right. So you wanna get into what you're gonna show us today, Mr. Nills?
Yes, I can get into something I'm going to show you today, and it's actually linked just a little bit to what we discussed in the previous stream, because the topic for today is two things actually. One is AAD pod identities, and the second piece is how that integrates with Key Vault. And both are important concepts to know when you're building a application on top of Kubernetes, because one, apps on Kubernetes will likely have to interface with other
services.
Yes, I wanted to say things, but services is a better word. And for instance, they have to get data from a Cosmos database, or they have to download or upload files in Blob. And or managed identities in Azure is typically the way we advise people to do so. And AAD managed pod identities makes that a little bit more manageable on Kubernetes itself. And then the second piece, tangentially related, is related to Key Vault and how you can securely access secrets stored in a Key Vault from within Kubernetes. There's a couple of ways to do it, but one way to do it is using something called a CSI driver, where CSI stands for Container Storage Interface, and it's just a standardized way for you to be able to access files wherever they are stored. And there's a CSI driver for Key Vault, which makes it easier to access secrets stored in a Key Vault from within your Kubernetes applications or pods.
Very nice.
That, in a summary, is what we'll be discussing today.
Looking forward to it. Let's do this.
Yes. Do we want to start with maybe some high-level whiteboarding about first the what, then maybe the why, and then the how?
Yeah.
Cool. So, just as a question, are you able to see my whiteboard?
Oh yeah. We can see it.
Okay. Cool. So, let me start the explanation. Let's maybe just start with a very quick intro into managed identities themselves. I believe you've covered this on the stream before, but just as a quick intro for those who don't know, managed identities are a way for a compute resource in Azure could be a virtual machine, could be a function, could even be an Azure Data Factory, to get an identity in Azure that they can then use to connect to other services. So if we think about it from, let's say, the context of a virtual machine, let me just draw a box representing a virtual machine. You have an app running in that VM, and if the app needs to connect, let's say, to blob storage, there's multiple ways this could be done. And I think before managed identities were a thing, typically what you would do is you would configure your app with a service principal, and you would either configure your app to use username password to authenticate, or use a certificate to authenticate against Azure AD. But then the question was, how do you securely store those passwords or the certificate that your app uses? What managed identity provides you is it provides you with a, let me just call it an endpoint, and I can add a little bit more about the endpoint in a second. But it's an endpoint that's only available from within the virtual machine itself. So that endpoint is hosted on a non-routable IP, where your app can make a request to that endpoint for essentially for a token.
Now, there are two ways to work with managed identities, right? One is, as a developer, you hand roll the code that looks into that endpoint and goes and acquires a token, but you can also use the Azure SDKs to do that for you in certain scenarios, right?
Yes.
Yes. Cool.
And your app would call into the endpoint to get a token. The endpoint then behind the cover, so this is something that you don't see and you don't manage. The endpoint would then do an authentication with that managed identity to Azure Active Directory, which will return the token to the endpoint, and the endpoint will then return the token to your app, which will allow your app to use that token to access and get data out of blob. Just as a little sideway on the endpoint itself, that endpoint is something we call the Instance Metadata Service, or IMDS. It's used for more than only managed identities. You can also use that to get some more metadata about the instance itself. So the instance knows, for instance, its name, things like its resource ID can also be gotten that way. But managed identities use that same internal endpoint. Now, the reason this gets interesting in, let's say, in the Kubernetes world is if we take that same context to, let me just say, managed identity in AKS. In AKS, all your nodes in your cluster are hosted on virtual machines. But on that single virtual machine, there are multiple pods running. And pods is just a concept of, let's say, one or more containers in Kubernetes. So you have those pods running. And if you were to configure nothing additionally on this VM, you still have the instance metadata endpoint that's available from within the virtual machine. If you were to configure nothing additionally on this virtual machine, those pods, or both of those pods, would be able to call this endpoint and get a token back, which in some cases might not be a big issue, but in cases where you're running multiple applications that need to be completely logically separated from each other, that could become an issue, which is where our first topic of today comes in, which is AAD managed pod identities, and I'm not going to write that full, but AAD managed pod identities, which essentially do two things. The first thing it does is managed pod identities intercept all of the traffic going to the instance metadata service endpoint and route that to something called the node managed identity. which is a container that's running on each node in your cluster. So step 1 is, let me just write that down, intercept packet. And step 2 is the node managed identity, let's call it container itself, can be configured with additional logic to check which pod is allowed to access which identity. So let's say this is just some additional logic around authorization.
Can a pod have multiple managed identities? Like, for example, if you're in Azure Web Apps, you can have the system assigned managed identity, and you can have user assigned managed identities. In fact, you have multiple of those. Is it a way for your pod to choose the one that they need to work with?
Two-part question that you asked. Answer to the first one, can a single pod have multiple identities? The answer is yes. Second part to your question, is that how your pod can choose which identity it accesses? That answer is no, because the only thing that the node managed identity checks is whether, let's maybe zoom in. Shoot, that was not what I wanted to do. So if I zoom in a little here, let's say we've got pod A and pod B. And pod A is allowed to access identity A, and pod B is allowed to access identity B. When you try to get a token from a managed identity, you typically, when you try to access a user-assigned managed identity, you provide the name of the identity that you want to access, or the client ID of the identity you want to access. And what the node managed identity controller does is the node managed identity controller checks that if A requests an identity, it will only return the token if A accesses the identity for identity A. And if it were to try to access identity B, that would not be allowed, and that would be denied essentially.
Interesting.
But if one of your pods would, let's say, pod B has access to multiple identities, identity C, you would have to do at client side, and I will actually, I could show you if I extend the demo a little bit. It's something you configure client side which identity you want to access.
So in the code, you mean, right? In the code, you say,
yes.
for this operation, I want to use this identity.
Okay. Exactly. Yeah.
Nice.
And so if we zoom out again, the way this then works is it's your pod makes a request to the from a pod's perspective, nothing changes. Like from a code perspective, you don't have to change your code. You still send your request for a token to the same endpoint IP address, that same non-routable IP that you would use in the normal case, like you see in the chart above. So your app has exactly the same code. It's then just the managed identity software that's running that'll intercept that traffic. It'll send that traffic to the NMI controller. The NMI will reach out to the endpoint. The endpoint will reach out to AAD. And then finally the token gets back. The NMI gets the token and then distributes the token to the right pods.
Is there a way to bypass the NMI and just tell the pod to go and grab the token itself, or would that not work in the Kubernetes environment?
So there is a way to bypass this, but that would require a cluster operator to configure that certain pods are allowed to bypass the NMI controller.
Right.
So from an application developer, you cannot bypass NMI if your operator didn't configure it that way.
Understood. Okay, so you always have to go through NMI, and that's the recommended practice, right?
Yes.
Bingo. Okay, sounds cool.
Yes. Do we want to see this in action?
Absolutely. Show us
Cool.
some code.
Yes. So just to show you what I already have is I've got a resource group pre-created where I have a managed identity already, and I will maybe zoom in a little to make this more readable. I've got a managed identity and I've got a storage account, but I have no Kubernetes cluster yet, and so I'll just create one on the fly and hoping that the demo gods are kind to us. I did prepare a little site to run everything.
Is the Pod Managed Identity preview feature right now?
Yes, that is a really good call out. So Pod Managed Identities are a preview feature. And maybe as a small little history lesson, thanks for calling that out. AAD Pod Identity used to be an open source project that Microsoft developed in the open on GitHub, and you could, I think that was released over a year ago already, and it allowed you to get exactly the same functionality as you'll see me use today. With the difference being that if once you install it from an open source project, it's your responsibility to maintain it, to update it, and to essentially support it as well.
Cool.
What the add-on for Kubernetes brings, because this is now an add-on into the Azure Kubernetes Service, is it gives a couple of benefits. I think the first one is it makes the installation easier. And I can, if I just quickly paste away the code here, enabling this is now as simple as just providing one command line flag enable pod identity, which is easier than having to set it up by installing the project itself. And the second thing that also provides is, since it's a managed add-on from Microsoft, well, if there are new versions, those versions will also automatically be pushed to your clusters. So you're always on the latest version that's supported and secured by Microsoft.
Right.
Can we add it to an existing cluster, or does it have to be set in the very beginning at creation time?
Right now, you have to set it at creation time. And that's something you typically see with new features in AKS, is when new features get available, they're typically only available for new clusters. And after a while, once there's more learnings from the preview, those features also get enabled on existing clusters.
Sweet. Can we zoom in a little bit, please, on the command line?
Yes. This better? Yep. So what we're doing here is we're issuing an AZ AKS create command in a resource group, and we're passing it a name.
Okay.
And I'm enabling two identity things. One is I'm using the enable managed identity flag. And what this option provides is, by enabling managed identity, you also let AKS itself use a managed identity to create and manage your virtual machines and your load balancers and your infrastructure. In the past, that used to be a service principal, which there's nothing wrong with service principals. It's just that managed identities are a bit easier to manage and to maintain. So that's why I use this as almost the default option when I create a new AKS cluster. We're enabling pod identities, and all the rest is just some more extra flavors, where I provide which network plugin I want to use. I configure a certain VM size to save some of my internal bill, and I just create a small 2-node cluster. And I generate SSH keys because I was too lazy to point to my own. But that's about it.
Weird question. Can you use spot instances to run a Kubernetes cluster, or is that not supported because of the unavailability of pod instances?
You can create a cluster using spot instances. And what's interesting in AKS land is a single cluster supports multiple node pools. And so you could create a single cluster with a regular, let's say, on-demand node pool that you know will always be running. and a second node pool that uses spot instances that would then be more where your workload, you could first point it at the spot instance cluster, the spot instance node pool, and if that node pool were to go offline, that workload could rebalance to your other node pool.
I love it.
Yes. And so typically creating a cluster takes about, I'd say about 5 minutes. And as I was saying this, here's the cluster. So if I were to show you this in the portal, we have our cluster right here. In essence, there's nothing special about this cluster itself, because the cluster itself is just a nice way to see your workload and see what's running and configured. What I did want to show you, because that's where we'll see some changes in a second, is in AKS, there's you have your AKS cluster itself,
right?
But you also have you also still have as an end user, you still have access to the underlying virtual machines. And so if we were to have a look at those, if you take your cluster name, you will always see in resource groups, you'll see that there's a resource group that's created with a special MC underscore prefix. You do have control over which name that resource group should be, but since I didn't provide any, it's just this MC underscore with your cluster name and resource group name. But if we go into this one, you will see the virtual machine skill set that is underpinning the Kubernetes cluster. So this one right here. And if we have a look into this skill set and we look into the identity that's configured here, you will see that it's already configured with, I believe, one managed identity, which is the agent pool managed identity. And that's the managed identity that AKS will use to make calls to Azure to add new machines to a node pool. If it needs to scale, it uses that same identity also to manage the load balancer. So that's one of the managed identities that got created based on this flag in the command line. But now what we want to do is, or what I want to do, and let me put it that way, is I also want to add my own managed identity to that cluster. And the way you do this is by these two little commands here, and I'll explain them as we're running them. First thing you have to do is you have to get the resource ID of your managed identity. So that would be, if I show that to you in the portal.
Interesting.
So you've got your managed identity. Come on, this one right here. So of this managed identity, I need to get the resource ID, and because I'm lazy, I just did that using the Azure CLI. So I got that.
That's
one.
Not lazy. That's efficient.
Yes, thank you, because I'm
there
efficient. And then the second thing we're doing is we're adding a pod identity to our AKS cluster. Again, providing the resource group name, the cluster name, and then we're providing two, let's say, Kubernetes specific things. One is we're providing a namespace in which the identity will be created.
Okay.
And then we're also giving the pod identity a name. And this name is, let's say, sort of important, because this is the name that we will use later on in our pod definitions to point to this is how the identity is called, and this is the label that will match to get access to this identity.
Okay, question time. Right, so the first command that you ran was about enabling the pod identity, but it didn't do anything. And with these commands, you're actually adding the identity to your Kubernetes cluster. Is that correct?
Yes, that's correct.
Okay.
Which
I'm
means
following.
that over time, you set up the infrastructure for pod identity once, but you can add more identities to your cluster as you go.
Right. So service A has its own identity, service B has its own identity, and so on and so on, if you want to go down that route, right?
Yes, exactly.
Okay, I'm following.
Okay, so let's get this to create. And this, I think yesterday when I ran it didn't take too long, but you never know. You never know. So this will now, this will essentially do two things in the background. The first thing it'll do is it'll link my managed identity to my virtual machine skill set that's underpinning my Kubernetes cluster.
Okay.
So that's the first thing. The second thing it's doing is it's then going into the AKS cluster and creating an object called an Azure identity in the cluster. The good thing about the managed add-on is you don't really have to manage and take care of those objects in Kubernetes because Microsoft does it for you based on this AZ command line tool. But you can still see the identity objects that are available in your cluster, and I can show them to you in a second once we're
yeah, that would be lovely.
once this is created. And so now we're just watching paint dry.
Hey, it's one of these things, right?
So this doesn't give us does this give us a secure cluster? So that I know there's this concept of a secure AKS cluster in the sense of using Azure AD to sign in and manage Kubernetes. This is purely for the nodes themselves and for the apps running in there to be able to use managed identity, right? These are two separate concepts? Yes. Okay.
These are indeed two separate concepts. I think what you're referring to is more of the security of the cluster itself.
Yep.
What pod managed identities focus on is not as much securing the cluster, but securing the workloads running on that cluster.
Yep. And then because this is essentially just intercepting any outbound managed identity calls, I can still get tokens for anything, right? I'm not painted into a corner where the only thing I can request tokens for is, say, other AKS resources or Azure resources or anything like that, right?
No, the token you get is a regular Azure AD token, and you can use that token for whatever you want to use it. Let it be accessing Azure resources, or if you protect your own APIs using Azure AD, you could even use that to access your own APIs if you'd want to.
Okay, cool.
And so the identity now got added, and so if we were to do a kubectl get Azure identity, what? Oh, I know what. Sorry, I forgot something. I'm not even accessing my AKS cluster yet, so that's a boo-boo of me. Just give me a second. So AZ AKS get credentials. And what I forgot to do was actually get my access to the cluster itself, and now I merged that context into my kubeconfig, meaning I now have the, let's say, secret to access my Kubernetes cluster. So if I now do kubectl get Azure identity, I should be able to see my identity that we just created. And if you look at this name, this access blob name, that is the name we provided here to link our identity to resources in Azure.
Oh, so it wasn't linked before. It wasn't
linked before. No,
okay.
Because we did this 2 minutes ago, and if we now go back to that same skill set we were looking at earlier, so I think it was this guy.
Okay.
And we check the identity section here. And user assigned. You see that earlier on we only had this agent pool managed identity. We now also have the blob access managed identity here. So now we can configure an application in our cluster to use that managed identity to access blob. So why don't we do this? So I did create some things already, and I can just show them from VS Code. If I make this big, I prepared 2 deployments already, and let me also zoom in here. So this is a deployment in Kubernetes that will go ahead and start creating pods for us. And what you see here that's special about this deployment is there's this label that specifies AAD pod identity binding is access blob.
That's the magic word there, right? Binding.
Yes, and that's how this deployment gets linked. And I'm actually highlighting the wrong thing. I should actually be highlighting it here because this is the important piece. This is where we link the pods that get created with the pod identity that we or the Azure identity that we created earlier. And then in terms of what I'm running in here is I'm running a Azure CLI container, just sleeping infinity, which will allow us to get access to that pod, connect to a shell in that pod, and try accessing the Azure CLI. So let's give that a spin. So we can create this using kubectl create deploy, -f deploy with identity. What did I do wrong? I did something wrong. Sorry. I think that's it was this typo I was complaining about. Yes. So now our deployment got created, and we can do a kubectl get pods and just watch it. This is in the background. What's happening now is this is downloading the Azure CLI container image. That takes a couple of I'd say seconds, minutes to pull in, and once the container image is downloaded, it'll go ahead and actually start our running container in, I'd say, about a minute. There's nothing special going on here, but now we have a running pod here. And so if I want to show you what this looks like, I can get its name. And in Kubernetes, there's this command called kubectl exec that you can use to execute a command in a running pod. And what I'll be doing is I'll be opening an interactive shell with this pod that we just created, and I'll just be executing sh to open another shell. And now I'm in the actual container where I have the Azure CLI available. So if I were to do az, you see that I have the Azure CLI available, which came pre-installed with this container image. And so I can now do an az login to log into Azure. And if I provide the flag -i, this then uses -i refers to identity, and this will then use a managed identity to log into to Azure. And I'll just do otable to make this a little bit more readable. And so as this is going on, what's happening here is I'll just show you here. So what we just witnessed was, let me just say, pod A, which had access to my identity, tried to get a token. That token request got intercepted by NMI. NMI forwarded it to the endpoint, to AAD, and we got a token back. And we now have a live shell to Azure, and we can then use this to interact with our blob storage account. And to do so, let's just create a small little text file. Any preferences for what we want to put in the text file, guys?
The 45, so obviously. Or you can do some, I don't know, some random text. Old guy shouts about the cloud.
So we now have this text file locally, and we can then use this to upload this to blob. And this I have to do from memory because that command I didn't write down. So the command is az storage blob upload, and maybe I'll just get some help.
Bing, Google is your help.
Yes, but az storage blob upload, and the file locally was text.txt, I believe, is what we called it. Text.txt. We'll upload that in a container. Let me just verify if a container already exists in that storage account. 4 to 5. And that'll also show you that I've got nothing up my sleeves.
We believe you.
So here we are. Let me copy this name as well, because we'll need that in a sec. Containers. And these are different containers from Kubernetes containers. And we'll call this 4 to 5 show. Okay, so we now have this container. So let's do 4 to 5 show as the container.
Can you scroll up a little bit?
Scroll up?
Yeah, because you're.
You mean
I mean the other direction. The text is behind your head. So.
This better?
Yeah, that's great. Thanks.
Oh no, that also doesn't work. I'll just do clear. Az storage blob uploads. The file was text.txt. The container was 4 to 5 show. We'll need to give the destination blob a name, but I'll just call it text.txt as well. We'll need to provide it with the account name, which should still be in my clipboard. And we'll provide it an I think it's off mode login. And this off mode login refers to the fact that we're using a managed or just an identity to upload to blob. And if I am well
so
prepared,
that'll be your local signed identity there. That whatever
Yes.
you sign into Azure CLI,
with.
right? Yeah.
Yes, exactly.
So,
And so-
technically, would you be using a service principal to run these, or is it okay that you're running it as yourself?
So I'm not running this as
Oh,
I'm
it's
not running it as
yourself?
myself.
Okay, sorry.
I'm so if I do az account show,
I
believe.
missed that. It's okay. Don't
So
bite my head.
I am. You see, my user
Yeah.
is a. I'm being an MSI, so I am a managed. I'm an identity.
Cool. Thanks.
So I'm curious about one thing. So when you take a user assigned identity and you assign it to a pod, right?
Mm-hmm.
Does that, if there's only one, does that assume the role of a system assignment? I noticed like when you did AZ login if you're
Yes.
using a user managed identity, usually you have to provide the ID of which one of the user assigned ones you want to use. Otherwise,
Yes.
it uses a system one. So the one that you're using currently, is that a system assigned one and actually system assigned, or is this one of the user ones that sort of mimics a system assigned one to the pod?
So, I'm somewhat certain about what I'm going to say, but not 100%. So,
Oh, good. Join the club.
yes. So, from a virtual machine perspective, so from a host perspective, the identity is still a user-assigned identity. The thing is, my request to sign in got forwarded to the node managed identity controller running on my node, and that node managed identity controller knows which identity my pod has access to. And because I didn't specify which identity I want to log into, and because there was only one binding, it just picked the one that it had access to. I could have specified which one I wanted to log into with providing in the AZ. What's going on? My terminal is not behaving, but okay. In the AZ command, in the AZ login command that I executed earlier, where did I do it? Yep, so here's where I did my login.
Yep.
I could have provided the parameter. I think it's -u for -user, and provided the client ID of the service principal or of the managed identity that I wanted to log into.
Yep.
So if a pod has multiple managed identities assigned, you could use that -u to specify which one to access.
Okay, cool. Yeah, that makes sense. Well, could you humor me for just a sec? So back in your AZ account show, could you grab that ID and let's go look at which service principal it is? So that ID property, we can do an ADSP show.
You're not seeing the ID is my subscription ID. I don't think you're actually seeing the ID of my identity here.
What is it? AZ login? AZ login show? One of the I know there's a command to see who you're logged in with, but now I'm starting to wonder if I forgot.
Yeah,
but it's fine. It doesn't really matter. I'm just curious what that identity, which identity that one is, the one that you're using currently. It's the one that you assign through pod identity, correct?
Yes. So let me see. Let's see if we can get that information. --sh AZ account help. No, it's the details of the subscription, not the details of the user. And there's no AZ login show.
Yeah, that's fine.
I don't know if there's a way to show you the identity of the user you're logged in with.
Yeah. What does your AZ account show again? It just shows MSI. It doesn't show it just says it's system assigned. Yeah. Okay.
Yes.
Now, what accounts or what managed identities have permission on your storage account right now?
Only the one we created earlier. So if we go in here, and we were to let me just first show you that the document is actually uploaded, or at least I hope so. So this is here, and if we were to go to the edit mode, old man yelling at cloud.
Nice.
And so maybe one good thing to show you, JP, is what were to happen if we don't include the AAD identity or the AD pod binding. So if we were to deploy something, because I've got a deployment without an ID here, where you see that in the labels there's no AAD binding here, which we had here. So here we have in the file deployment with ID, we're showing AAD pod identity binding is access blob. In this one, we don't provide the same.
Right.
And so if I can go ahead and exit here and create the cd git log.
So if you don't include that pod identity binding, right, then none of those identities are going to be bound to the pod. Does that essentially mean that there's no NMI at that point? There's no node managed managed identity running?
So the NMI is still running because the NMI is always running on each node in your cluster. The thing
Okay.
is, the NMI will intercept the AZ login request. So if I do kubectl exec it into the no access blob pod, and I open a shell in this one, if I do az login -i, now the thing that's happening, and this will take a little while to time out, but what's happening now is we're having pod B, which has no identities assigned at all.
Right.
It's making a request to the endpoint, and that request gets intercepted by NMI, and then NMI just checks, hey, which identities does pod B have access to? He doesn't have access to any, so it's not returning anything.
I will fail.
It'll fail, yes.
Okay, good. So the underlying system managed identity that's running on the VM itself, that's inaccessible unless you've explicitly allowed it, regardless of what kind of user identities are assigned to pods. If you don't assign any identity, then it's just as if there's no identity assigned.
Exactly. And
Okay.
that's what you see here. It's already failed, but it says MSI endpoint not responding. Please make sure that it's configured correctly. That's just because the NMI didn't return an error. It just timed out the
Yeah.
login request.
Okay, cool. All right, that's cool.
But you still
And so-
get the MSI endpoint is not responding, right? So this is something that if you are calling in code, you should catch in case no identity has been assigned to that pod.
Yes.
Right.
Yeah.
Okay.
And that's the, let's say, demonstration of AAD pod identities. Now, there's a second piece that I'd like to demonstrate today as well, which is how you can use those identities to access secrets in Key Vault.
Oh, nice.
You guys want to take a quick break before we jump into that?
Damn it!
Yep.
You took it out of my mouth.
Sorry,
Good.
reload-
I was gonna-
reload
No,
some,
it's fine. It's fine.
Reload your coffee.
We're synced. Like
Yes.
it. Yeah. 5
All
minutes.
right, cool. We'll be back in less than 5 minutes. I'm slow
Okay,
though. I've got to
cool.
hobble around, so you gotta work.
So-
with me
somebody
today.
should get it to you, man.
Yeah. All right. We're back. Thanks for hanging with us. So Nills has shown us pod identity, talking to Blob, which is useful, of course. And I think one of the most common things we get asked about when it comes to managed identity in general is Key Vault. And it sounds like you've got a little something for us there too, right?
Yes, there's a tool or an open source project available called the CSI driver for Key Vault, which makes it easier to access secrets in pods in Kubernetes as well, where rather than you having to call the Key Vault API yourself, which is something you certainly can do, you can avoid calling the Key Vault API altogether and have the CSI driver call Key Vault for you and make those secrets available either as a file in your pod or in your container, or make them available as an environment variable in the application you're running. And so,
Okay,
do we
cool.
want to do a quick show into what that looks like?
Yeah.
Yep. And also, this is different to the actual Kubernetes secrets, right?
Yes.
Because I think Kubernetes also have the ability to store and manage secrets for you, but it's always better and more secure to store them in Key Vault, right?
Exactly.
Okay,
The-
so what's a CSI driver? Sorry, let's start there. What's a CSI
Yes.
driver?
So CSI stands for, and I'll spell it out. Container
Crime scene unit.
storage.
Do you know what CSI? So many iteration. Crime scene investigator. JP, come on.
Interface.
That's what Robert says.
I mean, I guess
And-
if you're a Kubernetes admin, then you kind of take on
There's
that
a lot
role
of crimes.
on a regular basis, right?
Well, let's say that if you're running a application in Kubernetes and something goes wrong, it feels like a crime scene investigation. Because it's wonderful when things go right, but there are so many different places where things could go wrong. that it's a hell of a job to troubleshoot. But back to another CSI. CSI stands for Container Storage Interface, and it's a definition within Kubernetes to provide a single standardized way to interface with storage, rather than each different cloud provider and each different storage provider having their own sort of API to access storage. The container storage interface provides you with an interface that you implement on top of your storage system, and Kubernetes will always use the same APIs to access that storage system. So it's standardization. And what the CSI driver for Key Vault allows you to do is essentially from the point of view from a, let's say from the point of view from a pod, you have a pod, and a pod can have volumes attached. Let's call this a volume. What the CSI driver for Key Vault allows you to do is this volume, so this thing could be Key Vault. Key Vault secrets or keys or whatever, but let's just call it Key Vault secrets for now. Could be keys, could be TLS certificates as well in Key Vault. But it allows you to mount those as a volume, which is, let's say, the first thing it allows you to do. A second thing it allows you to do as well, which I'm not a big fan of, but it's something that's possible. Once you have a volume mounted to a pod, it also allows you to, let's say, come on, work with me. It also allows you to sync Key Vault secrets with Kubernetes secrets.
Ah, interesting. And I'm assuming that's based on the identity of the pod, of the cluster. How is that secured, or how is that authorized?
Yeah, so that's a really good question. And if we think about pod interfacing with Key Vault, there are multiple ways this can be done. I think the first way is the service principal way, where you just configure a default Kubernetes secret with service principal name and service principal secret or password, or potentially a certificate. I think that also works, although I'm not sure. That's one way. Second way is by using a system assigned or even a user assigned managed identity, but without pod identities. So that would mean just assigning an identity to your cluster itself, and without pod identity being on the cluster. As I mentioned in the introduction, each pod can reach the system assigned or user assigned managed identity, and it just grabs that token and uses that to interface with Key Vault. And
so does that mean? So that means then that I'm essentially connecting to Key Vault as the whole cluster. So each individual pod, if I needed each individual pod to access Key Vault and access its own secrets, I'd either have to code that myself with the service principal, or I could use pod identity and talk to Key Vault directly. I couldn't use the CSI driver though.
You could still use the CSI driver. The only thing is you're potentially a little bit overexposed from a security perspective, because with managed identities on your skill set, without pod identity, each pod can get a token, and then each pod could use that token to get access to Key Vault.
Right. Okay, makes sense.
And so the third way, which is the way that I'll demo you, is the way using AAD pod identities, where each individual pod can have an identity assigned, and that pod would then use that identity to go ahead and access Key Vault. Make sense?
Yes.
Yep.
Cool. So let's get started. And as I showed you, I have a little script available that helps with some of these things. So we stopped the previous one where we assigned the managed identity to the cluster. So what I'm going to do now is going to create a key vault and set a policy on my key vault. Create a key vault, create a secret in Key Vault, and then set a policy in Key Vault that my my identity, which I still have to get because I'm in a new shell. Let me just grab this as well and add that here. So again, getting the client ID of the identity, because that client ID will be assigned permissions over my Key Vault secrets. So quickly going to get this and run this. So it got the client ID, it's creating the Key Vault. Shoot. Bear with me for a second.
And this is running as you, right? Because you're signed into your
Yes.
local CLI as you?
Yes.
Okay.
Yes. Sorry. I made one mistake where I created all of this yesterday to prepare for this, but my Key Vault had soft deletion turned on, so I cannot use the same name. So just trying this again. And I'll put this a little higher so you can follow better. But it's creating a Key Vault right now. Then it'll create that secret and set the policy. And we'll be able to see that. I'll verify this in the Azure portal once everything is created. Okay, that was the Key Vault. Secret gets created, that's not too interesting to watch, and then the policy gets set. Okay, all of that's done. So if we go back to our resource group, you now see that we have a Key Vault in here. Some more. So we have the Key Vault we just created. If we check secrets, we'll see that we have this secret 425. And if we check access policies, we also see that our application, it's called blob access. I should have actually done better naming, but our application now also has access to our Key Vault. Now, next thing we have to do is we have to set up the CSI driver itself. The CSI driver is available. This is an open source project. So if you were to have a look for GitHub Key Vault here, so the secret store CSI driver, and I'll. Do you want me to share this in the chat as well, JP?
Yeah, sure. Be great.
Yeah, please. We'll share them on the YouTube video later on, so you should be able to find the links right below.
Okay, cool. That's in the chat. And so to install this, installation itself is super simple, super well thought out through Helm. It's essentially running two commands, one of which I already ran. The installation is just adding a repo to Helm and then doing a Helm install, which I'll get here to install it on the cluster. And that's all that's required to install the CSI driver, which is super well thought out by that team. Big kudos to them for making this installation so easy. So I'm running the Helm install right now. It got deployed, and what this does for us is if I were to do a kubectl get CRD, and I'll explain what a CRD is in a second, but you now see that we have these two new APIs available in Kubernetes, being a secret provider class and a secret provider class pod statuses, which we won't use today. But this allows us to, this secret provider class object is an object in Kubernetes that will create to link our secrets in Key Vault to something that Kubernetes can access. And I'll show you what these ones look like in a second. I did use the command kubectl get CRD. And for those who are not as familiar with Kubernetes, the Kubernetes API by itself has support for a number of objects. Those objects are pods, deployments, services, and a number of other things. But the API of Kubernetes is extensible by something called a custom resource definition. And what a custom resource definition gives you in terms of capability is it allows you to use the same Kubernetes API and the same tooling like kubectl create to create custom objects that Kubernetes as an open source project isn't aware of, but that you can support from just within your own cluster, which is what we're doing here with the secret provider class. And so to link a secret in Key Vault to something that Kubernetes can use, we have to create something called a secret provider class. And let me show you what that looks like. So I've got one right here. And so this is the secret provider class, where this is something that's linking to Key Vault. And here I'm saying that I'm using, or that I wanted to use Pod Managed Identities. I provided an array of objects that I wanted to pull from Key Vault. In our case, there's only one secret in our Key Vault, but as a single secret provider class could contain multiple secrets. If there's, for instance, an API endpoint, API token, and multiple things that you have to get your application to function, you could do this using an array of objects in a single secret provider class. We provided a tenant ID, which is the tenant ID that the identities will live in. And what we see here in lines 16 to 21, this content is optional. This is not at all required, but just to show some of the capabilities of this provider, what lines 16 to 21 do is it links the secrets in Key Vault to a secret in Kubernetes. And so this allows you to then also use those secrets the same way you would use them in a regular Kubernetes deployment. There's one gotcha with the syncing to Kubernetes secrets, and that is by default, or the way this works is the secrets will only be synced to Kubernetes secrets if a pod with permissions on the Key Vault is accessing those files through a secret provider class. But I'll show that in a second because it'll be more clear when I create everything in a second. So, any JP, Christos, any questions about this?
No, all good. Following along.
No.
Okay.
I mean, I have lots of questions, but I'll save them.
Okay.
I'll save them for later.
Okay. I hope it'll become clear at least. So first thing we have to do is we'll create this SPC that we just defined, and this will just create the secret provider class itself. This in itself creates a sort of volume definition on Kubernetes, but it doesn't yet access the secret. The secret only gets accessed once you create a pod with permissions on the secret that then needs to access the secret. And so that's where this pod with secret file comes in, where as you see again, we're using the AAD pod identity binding to be able to access the secrets. And then the interesting pieces are here. First thing to highlight is lines 21 to 27 right here, where I am creating a volume called Key Vault and pointing that using CSI, which is where that default or that standardized driver comes in. And through CSI, I'm pointing that to the Key Vault secret provider class that we created earlier. And if we check this name, Key Vault secret, that is the same name as the name of the secret provider class we created. And one thing you could do in a cluster is for different applications, you could create different secret provider classes, and those different classes could refer to either the same key vault but different objects, or even different objects in different key vaults. That doesn't matter too much. But then if we check our pod with secret file again, so we're getting the volume. We are then mounting that volume again in the pod itself. So once we open a shell into our pod, we'll be able to get to this path and see the actual secret in there. And then the final thing I'm doing is here. I'm also setting an environment variable. And for those of you who are familiar with Kubernetes itself, here I'm setting the environment variable Key Vault secret by pointing it to a secret key reference. And this name here, called Key Vault secret, is not a link to a secret provider class. And I should have been more creative in my naming. But this one, the secret key reference, if you look at this with this name and this key, that is a reference to the synced secret object that we're creating, where we're creating a secret with the name Key Vault secret, with the key being secret content, and that's how we're getting that environment variable set up in Kubernetes. I hope that's clear. Ready to create this?
Yep. Go for it.
Okay, so kubectl create -f pod with secrets. And then we can get the pods and watch them be created. So we're watching for this guy, CSI demo, to be created. And if this is running now. So now that this is running, we can do a kubectl exec-it into this pod and open a shell. And now that we're in, let's go into this path, because this is the path where we were connecting to the secrets. So if we go here you'll see secret 425. And if we were to get access to the contents of this file, you'll see that this is the super secret for the 425 show.
I love super secrets.
And then that's also in your environment variables now too, right?
Yes. So if I were to do echo Key Vault _ secret, you also see that I have my super secret for the Key Vault for the 425 show mounted as an environment variable.
Oh, that's cool. So then, excuse me. So things like certificates that are stored. Like say I've got an Nginx container running and I want to load up my cert out of Key Vault. Is that can we access files, or is it all just text-based string secrets?
No, you can access the TLS certificates in Key Vault as well. So you can you can access those as well. That's where in the secret provider class, you see here as object type, I'm now referring to a secret, but I could also just refer to a non-secret file in Key Vault that would be a TLS certificate and get it that way.
And then that's using the pod identity that you assigned earlier, that 425 blob access. That's using that pod identity to go and make that call, and then this handles all of the work of connecting the Key Vault and showing it as a file system and doing all that sort of stuff.
Yes. And
that's pretty
to maybe
cool.
show you to maybe show you how that could potentially fail, let's do a new file, and let's do CSI demo fail. And if we remove this AAD pod identity binding and keep all the rest the same, CSI fail. And so we're still trying to get access to the volume, still doing all of the same things. I might have to... No, I don't have to change anything else, because this is just a pod. But if we create CSI fail, kubectl create CSI fail, that pod gets created, and we can do a kubectl get pods watch. And you'll see that this demo fail pod, at least my expectation is that it stays in a container creating failed state. And we can watch this for a couple of more seconds to see that it doesn't change statuses. But if
so that'll just never deploy, which is, I think, probably pretty good, right? Like, you'd want it to fail if those secrets weren't available, because if they weren't available because it was misconfigured or whatever, then chances are your app isn't going to run correctly anyway.
Exactly. And because it cannot access the key vault, this doesn't get created. And if you look into the, let's say, the logs of this thing, it actually has a failed mount, and it says that it failed to get key vault client, failed to get the key vault token, and a my response failed with status code 404. So that tells you that you're not able to access key vault.
Right, because in the 404 is because there is no NMI at this point, or sorry, there's no, because we haven't assigned a pod identity, there's nothing there for it to use.
To get. Yes, exactly.
Now, because you didn't bind a pod identity, but your cluster has pod identity enabled, that's why it didn't use the system managed identity that's assigned to the total cluster?
Exactly, yes.
Okay, so had I not done pod identity at all, like in the cluster deployment, then it would use the managed identity of the cluster to get there, right?
Yes.
Because then there's no NMI at all, unless I've got that pod identity enabled for the cluster.
So I'd say yes, but with an asterisk, because in the secret provider class, we defined that it has to use pod identity.
Oh, okay. So you'd have to take that out.
Yes, you'd have to take that out, and you then have to configure it with the other identities to use.
Right.
So you would then have to give this, I believe you'd have to give this the client ID of the either system assigned or user assigned managed identity so that it can call the right token.
Right. Okay. Yeah, that's cool. Neat.
Yeah.
It's pretty cool. I like that a lot.
Let me show you the final thing that I wanted to show you is we can now also get the Kubernetes secret. So you now see that we have our Key Vault secret here that we synced over. And if I were to delete the pod, because what I mentioned earlier is the secret syncing only works as long as a pod with access to that secret accesses that secret. So if I were to do a kubectl delete of my CSI demo, and it's a pod, so of pod CSI demo, this is the only pod that had access to the secret. I am now, let's say, sort of assuming that if I do kubectl get secret, that the secret is no longer there, as expected.
Oh, sweet.
So yeah.
Mm-hmm. Neat.
Yeah.
That's pretty cool.
It.
Yeah. No, I like it. I mean, I think it's interesting how, I'll be honest, and maybe you can help me with this, Nills, because obviously you do a lot of Kubernetes work. So, the thing that's interesting about this is, right, is like, so years ago, if I was like big enterprise, and I wanted to build a box, like I wanted to build an app, I'd have to call like 30 people and put in tickets, like, I need somebody to build me a machine that matches all the standards and blah, 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 right? And somebody would stand up a machine, and they'd carve out network, and they'd carve out storage, and they'd install all the right web servers and get all that configured, and domain join, all the typical stuff that you do, especially like in a Windows shop. Like if you're using Windows Server, which I get isn't like a super common thing. But even then, we still have plenty of people configuring Linux servers. So we did all this work, and so we had this environment, and the way it was is the way it was. But so now we've got this app, and that app is sort of... it's pretty much intrinsically bound to that hardware. Not that specific server, but that specific configuration, and with that entire environment configured in that way. So, like, not just the node that it's running on, but also the fact that it's maybe in a domain environment, and there's a Kerberos server available, and there's this, and there's that, and all these different things available, right? And so my ability as a developer to extricate that app, pick it up, and move it somewhere else is essentially zero. Because somebody's got to go configure all that other stuff for me. Or I've got to script it or whatever. How it gets configured is really neither here nor there. So that was one side of the pendulum. And then the pendulum swang to be more sort of like, hey, your app needs to do a lot of stuff, and so your app can run anywhere. You want to run it in the cloud? Cool. You run it in the cloud. You want to run it in a container? Cool. Go run it in a container. You want to run it here? You want to run it there? On-prem? Doesn't really matter. But now it seems as though we've almost shifted back the other way. You've got like dozens and dozens of lines of YAML and all of this infrastructure that you have to set up in order to get an app to work. And as long as the right pieces are in place at runtime, that app's going to say, cool, I got what I need, and it's going to go run with it, right? So I guess the thing I'm wondering is, A, am I just being obtuse and not understanding everything correctly, or not understanding why the big shift this year, or shift this direction? Or B, is this just sort of what it is now? Like, people want to do this. This is what ops folks want. This is what developers want. Like, I'm just kind of curious because we see so much discussion around Kubernetes. We see so much discussion around, getting things deployed. And for me, at least, now, and granted, I'm fairly biased, so I know I'm not an objective, impartial observer here, but it just seems like a whole lot of work to run an app.
It is, and you made a couple of really good points. I think I don't look at it as a pendulum. I'd rather like to look at it as sort of a continuum where on the, let's say, the left-hand side you have purpose-built hardware for just that single app. And on the right side, you have serverless functions.
Right.
And I think every developer's dream is to be able to run on serverless functions, because you just write code and you don't worry about infrastructure at all.
Yeah, like I want to write code and then get up and leave. And that's it. I just write code, like, oh, okay, semicolon, walk away, enter, go.
Yep.
That's what I wanted. That's where I want to be.
That's where I think that's what the community is working towards, and I think Kubernetes is a on that continuum is somewhere in the middle, maybe even closer to purpose-built hardware than to serverless function than other things like an app service are, because with Kubernetes you as an organization, I don't want to speak about roles yet, but as an organization, there's a lot of things to manage. What we just did with AAD Pod Identities is, again, something you have to enable, and you have to run some CLI scripts to tie an identity to your cluster, and then you have to add labels to your pods and all of that thing, whereas in app service or in functions, that's built in.
Yeah.
And what I think is happening is in the whole swing from, let's say, legacy type 1 infrastructure as a service, and I'll explain type 1 and type 2 in a second, but from the legacy type 1 infrastructure going to functions type 2, just applications running, I think new applications fit some new applications, let's say new web-based applications fit really well with functions as a service model, but there are still a whole lot of other applications that do not work on functions as a service. If you think about high performance compute simulations, or if you think about anything that has to be real time, like voice, like we're talking right now over OBS, or if you're talking over Zoom or Teams, those types of real time communication workloads don't fit for functions as a service. And what I think Kubernetes does really well, and Kubernetes is way too complicated for your average application. I do a lot of work with Kubernetes, but I think that services in Azure, like an app service or even an Azure Functions, are a lot easier to set up and a lot easier to manage. But where I think Kubernetes gained a lot of mindshare is for a number of reasons. I think one is Kubernetes really gives you that sort of, I don't want to say perfect balance, but Kubernetes found a really good balance between offering you a standardized environment with enough options for customization. Like if you think about high performance compute simulations, those need to run on very particular hardware. Well, Kubernetes can run on that particular hardware. And so you have that customization capability of Kubernetes to run it on whatever hardware you want to run it on, even on ARM processors or on the Raspberry Pi. But it has that standardization built in that allows you to do DevOps and infrastructure as code and deploy applications way faster than you had to do in the past. Because in the past, you had to call 30 different people to rack and stack servers and set up VMware and create virtual machines. Whereas now with Kubernetes, once somebody has set up a cluster, you can create your own disks using the CSI driver, you can manage your own network, you can manage your own deployments, and all of that is a lot easier. And I think Kubernetes, the reason it got adopted so widely is because it found that sweet spot between productivity and ability to customize.
So let me ask you something I heard. It's probably 2 years old now, so we've probably only got a few years left. Somebody once said that in 5 years, the only people who are going to run Kubernetes themselves are going to be service providers, like an Azure, like an AWS, like a Google, right? Mm-hmm. How true? And obviously, we know that enterprise moves at a snail's pace, and that there are still people who are just now cranking up VMs in 2021. So I totally get that part, but I'm thinking of in the general sense, right? As Kubernetes matures and as the ecosystem around it gets even larger, because it's absolutely massive now, but as the ecosystem around it gets even larger, how long before me as a developer, or maybe me as an ops person, how long before I say, I don't need to deploy my own cluster. I'm just going to write against some higher level API, and now maybe this is functions, right? Maybe it is something like that. Like, how long before deploying your own Kubernetes cluster is seen as a task only for a select few?
I think I want to clarify the question before I give an answer. I think the first thing I want to say is I think services
he's putting you in the corner over there.
No, I'm not. Yeah. I'm not trying to be obtuse. I'm genuinely curious because we get this question a lot, and I struggle sometimes to come up with a good answer for why somebody needs to do this. And me personally, it's very hard for me to look past my own experience, because my own experience in this case is I've been doing cloud stuff since 2010. So my first app that I deployed was an Azure Azure Web App and Worker Role. So then I had to write a bunch of XML to configure my deployment, and it was a huge learning experience, and I learned a lot about one node versus 500 and scaling and all that sort of stuff. But I was also pretty hooked on it, because I wrote my code and somebody else did all the work of hosting it and deploying it and running it, right? And when we look at everything that goes into this, now I feel like I've got to go back the other direction to start figuring out, okay, well, what does it mean for me to describe my infrastructure in this way? Like, I need this runtime, I need these kinds of services available, and I want it to scale both up and out as I get usage coming in, right? And it was a blend of apps. It was everything from TCP-based services, HTTP stuff, 4 or 5 different things. Certainly nothing like of some massive scale, but big enough and compartmentalized enough that it was multiple roles that went out and that sort of thing. And it was, this feels like I would have to both own the entire stack underneath it and the software code that's running on top. And I'm just trying to fully grok the massive popularity, especially right now, 10 years later, right? Of why this is, and why this is such a common recurring theme of, we got to do it in Kubernetes. This is going to be something we're going to put in Kubernetes. I want to build my own cluster. We've got a massive cluster we're going to use to do this sort of thing. I'm trying to figure out what's my benefit, especially developer side. What's my benefit for learning everything there is to know about standing up clusters and being able to get my apps out there.
So to answer that question, I think, or about your 5-year perspective, I think there are still going to be companies that roll their own clusters. I think companies like, I think OpenAI is pretty public about their big usage of Kubernetes. Reddit is the same. And once you go to a certain scale, I think certain companies will still want to run and configure their own cluster to really have their hands on the metal. But I think services like AKS, EKS, GKE, and even Red Hat OpenShift for that matter, even in an on-prem deployment, and then things like Azure Arc and Google Anthos and AWS with EKS Anywhere. I think you're seeing an evolution where cloud providers are making it a lot easier to create and manage clusters, which is a very good thing. But I still think that somebody in your organization will care about the cluster. Where I see things change in 5 years, and let's hope we get there sooner, is in the abstraction between the Kubernetes API and what you as a developer have to know and supply. And it's a difficult balance to find. And there's different points of view. There's, for instance, there's the Kelsey Hightower point of view, and Kelsey Hightower is, let's say, one of the leading public figures at Google for Kubernetes. He sees Kubernetes as a platform to build platforms on. Like, you use Kubernetes to run something like an Azure Functions on, or a Google Cloud Run with Knative. And I'm being very cloud agnostic here, and maybe I should be more Microsoft specific, but your question was really about where things are going. And I think that as a developer, even today, you shouldn't care much about Kubernetes principles. I think that as a developer, you should supply your code. You should supply your code with a Docker file to packages in a container, because one thing that I will go on a soapbox for and stand on is containers are a fantastic packaging mechanism. Containers make it super easy for you to package up your applications and the dependencies that you know it has together, and it makes it super easy to deploy your application wherever it has to run. And I think, but the developer's responsibility should end, if we talk about pure developer, at the Docker file, I believe. Once we go into Kubernetes YAMLs and configuring deployments and ingress controllers and the CSI drivers for secrets, I think that responsibility should not be on the developer. That's, as today stands, I would say that's more the responsibility of an SRE or a site reliability engineer, or if you have a DevOps engineer, although I don't think there is such a thing as a DevOps engineer.
Yeah, kind of defeats
Be careful
the purpose,
there.
right?
Be careful.
Yes,
careful.
I said I thought there is no such a thing. I didn't say there is no such a thing. I said I thought.
Personal opinion. Yes, exactly.
Yes.
Well,
And
that's the
everything
whole
I'm
point
saying-
of DevOps, right? Is that nobody's a DevOps engineer. Everybody's an ops engineer. I mean, or somebody there knows ops, but it's still one integrated team. I mean, it's 95% process and 5% tools.
Yes.
But DevOps feels like it's so overloaded now and has so many meanings that it doesn't even resemble what the original intention was of it, right?
Yes. And whether to get back to maybe make my point crisp in like a 1 or 2 sentence is, I believe that developers already today shouldn't care about Kubernetes, and where I see the community evolve and all of the traction around it is, I think developers and even SREs and people in a DevOpsy type role will have to care less and less about Kubernetes. You will still have a cluster, and you will still have somebody operating the cluster, but what gets deployed on the cluster will get simplified.
Yeah. Well, I think that's the thing, right? Is if I can take my app and I can lift and I know there's a very strong difference between what you should do when you're writing software versus what people actually do, because they have deadlines and budgets and everybody's got to get stuff done. But I mean, ultimately, at the end of the day, I should be able to take an app that's an app that I've written a Docker file for, and you as a consumer can run it however you want. If you've got something that'll run a container, then you can go and run it. It doesn't matter if it's running in Kubernetes and ACI and whatever vNext of container technology looks like, or container orchestration technology looks like. Ultimately, it really shouldn't matter. We all know that things get leaky, and we have a deadline we have to meet, so we're going to take a hard dependency on an environment. But no, it's cool. I appreciate it. Like I've always felt that way, as sort of like, this is cool, but like not this being what you showed us today. I meant container orchestration in general. Like, this is cool, but why? Like, I'm just left sitting there thinking, like, why should this really matter to me? And it sounds like you're telling me it doesn't need to. So I'm good. So I can continue in blissful ignorance.
There's no business value in Kubernetes. There's business value in the apps you deploy on top of it. And so if you can make Kubernetes easier, you make it easier to create business value. And that's, in essence, that's what we're here for. I love my technology, and I love geeking out on things like pod identities and CSI drivers. But in the end, I'm learning about this to be able to help my customers build apps on top of Azure and create that business value. That's what we're here for.
Yeah. Okay. No, that's cool. I appreciate it. I appreciate you entertaining and humoring me for a little while. I'm always worried to talk to people about why I don't fully understand why Kubernetes is so popular, because some people have gotten extremely upset with me in the past. And so, like a wounded dog, I'm like, oh, I don't know if I want to breach this stuff. But I'm super curious, so thank you for taking the time.
And I love this discussion, and I should have prefaced it with, I'm expressing my opinion when I started answering your questions. Because it's a very difficult topic to zoom in on, because there is this hype around it, and I think it's no longer a hype. There's adoption. You see so many different leading brands being public about their Kubernetes adoption, let alone brands that are not public about it. So it is here. Yeah. It is here to stay, but I'm fairly certain that it'll get simplified.
Yeah. That's cool. Well, thanks for coming and hanging out with us. It's we're getting close to the top of the hour, so time worked out pretty well this time around, which is awesome. So, well, thanks for coming and hanging with us. We're gonna get out of here because we got to do a show tomorrow. So we got our Tuesday show tomorrow. I think, Nills, you are our last Monday guest. So as of next week, we will be back on Tuesday, not next Monday. We'll be back tomorrow on Identity Crisis, and Friday we've got our normal show. But next Monday we will not have a show. Instead, that show will be on Tuesday. So, so thanks to Nills for coming. Follow him on Twitter. Go get his book. We will make sure there's a link to the book that he's writing or has written and is now updating about hands-on AKS. Feel free to join us in the Discord. Nills, are you in the Discord? Have you joined the Discord yet?
No. Discord is a social medium that I'm not using at all.
Okay, well, good. So his first channel is going to be the 425 show, and and yeah. So so the links are up at the top of the screen. We'll put them here in the chat too. It's AKA.ms 425 show Discord /join. there's usually some interesting conversation going on out there. There's a good one a couple weeks ago about our irreverence towards older technologies. It was an interesting convo. There's somebody's taking a C# class right now and is learning all about ORMs and database, which is cool. So feel free to come hang out in the Discord. We're there all the time and get your questions answered. And yes, thrashing code. There are a lot of things that we should do that we just haven't done yet, and we need to do, which we will do.
Send us ideas. Send us ideas on on Discord or email or whatever you want to reach out to. We're always open to suggestions.
And if there's a Kubernetes topic, I'll be back.
Yeah, if there's a if you have a Kubernetes question, you can send it to us at 425show@microsoft.com. However, we will forward them all to Nills directly. So we will I will set up a rule today that if it says Kubernetes or Pod or Container or KAS or AKS, that I will auto forward to Nills, and Nills will be there to answer your question. Anyway, come hang out with us at Discord. Send us an email if you'd prefer. 425show@microsoft.com. Of course, we're on Twitter. Our names are all there. Next to our faces, so feel free to follow us and bug us out there, and we'll do everything we can to get your questions answered. So until tomorrow, we're gonna make like the fat kid in dodgeball and get out of here.
Yeah. Well, I need to show my name. Thanks, everyone. Have a nice day.
I think everybody knows there's the @ there, right? So I mean, the @ is no big deal, but
I
anyway,
hope, I want to be I want to be explicit.
Anyway, we'll see y'all tomorrow. Have a great afternoon.
See you all. Bye.
Thanks for hanging. See ya.
Thanks for having me.